Welcome to the class, students. Today we are moving to next topic in analysis of univariate data, and this is our last topic, that is moments. Moments are popularly used to describe the various characteristics of a frequency distribution. We can see the characteristics of frequency distribution such as average, dispersion, skewness and kurtosis. Already we have discussed about central tendencies and averages and dispersions, and in moments we will see how it will be the characteristics of frequency distribution in skewness and kurtosis. Okay, we have two types of moments here. One is raw moment, another one is central moments. Okay, raw moment is nothing but any particular arbitrary point, we will consider it as a raw moment, and the moment about the mean are known as central moments. Okay, if you take the central values, then it is a central moment, and if you take a particular point, then it is a raw moment. Okay, to calculate this we have coefficients based on the moments, that is Kpis coefficient and gamma coefficients, but here in this class we are using only coefficient of skewness. We will discuss about this coefficient of skewness. Let us see what is skewness. Skewness is nothing but a lack of symmetry or asymmetric. Okay, for example, if we have two frequency distributions, let me write the frequency distribution. This is the first frequency distribution, X and F. X values are, I will write here, 3, 9, 15, 21, 27, 33. This is the frequency distribution. And for same x values, this is the second frequency distribution. For same x values, I am taking 3, 9, 15, 21, 27, 33, and frequencies are 10, 40, 30, 90, 20 and 10. You just observe these two frequency distribution. In this frequency distribution, the frequencies are symmetric. You just see your 60, 30, 10, 60, 30, 10. This is symmetric about the central value. But for the same x values, here in second frequency distribution, the frequencies are varying. We are having different frequencies. So in one distribution for the same x values, in one distribution the frequencies are symmetric, and for other distribution the frequencies are not symmetric. But if we calculate mean and standard deviation for these two frequency distribution, it will be a same. Okay, for both the frequency distribution, mean and standard deviation will be same, but their characters or the distribution of the values, frequencies are different. The dispersions are inadequate to characters of frequency distribution. The dispersion is nothing but the variations in the given data. In first frequency distribution, we see that frequencies are equal either of the central values, that is it is symmetric, whereas the second frequency distribution are unequal on either side of the central values. Our central values ge ಮೇಲೆ ಅಥವಾ ಕೆಳಗೆ ಎಲ್ಲೂ ಕೂಡ ಅದು ಸಿಮೆಟ್ರಿಕ್ ಆಗಿ ಇಲ್ಲ, ಸೇಮ್ ವ್ಯಾಲ್ಯೂಸ್ ರಿಪೀಟ್ ಆಗಿಲ್ಲ. ಓಕೆ, and thus there arises a need to study whether the scatterness of value around the central values are symmetric or not symmetric. Here we want to see whether the values are symmetric or not symmetric, that we are going to study in this skewness. So skewness refers to a lack of symmetry or asymmetric. I will write the definition for skewness now. Definition of skewness. The definition of skewness is, skewness refers to lack of symmetry. Lack of symmetric. This lack of symmetric word is very important, or lack of symmetric is nothing but asymmetric. Lack of symmetry is nothing but asymmetry. Lack of symmetry and asymmetric, this is very important word in the definition of skewness. Let us see some properties of skewness. Okay, let us see some properties of skewness. First property says mean, median and mode are equal. Mode are equal. Okay. Properties of, this is symmetric distribution, not skewness. Properties of symmetric distribution. When do we say that the data is symmetric? This is symmetric distribution. In symmetric distribution, mean, median, mode are equal, and median is equidistant from the lower and upper quartiles. That is, Q3 minus Q2 is equal to Q2 minus Q1. Here Q2 is median. Q2 is median. We know that Q2 is median. The distance between the upper quartile, that is Q3, and to median, and from median to lower quartile, it is same. When the symmetric distribution is plotted on a graph, we will get a bell-shaped curve. Bell-shaped curve. We will get bell-shaped curve, and it is only, here we are having only 3 properties of symmetric distribution. Here mean, median, mode are equal, and the median will be equidistant to the quartiles, and if we plot the distribution, we will get the curve in bell-shaped. And here we have types of skewness. Next is types of skewness. Types of skewness. One is positively skewed distribution. Second one is negatively skewed distribution. This we will see in the, when we solving the problem, we can see whether it is positive or negative skewed distribution. Now I will show the diagrams or a graph of positive and negative and a symmetric. This is Z less than median less than X bar. This is positively skewed curve. This is positively skewed curve. This is negatively skewed curve. Negatively skewed curve. And to show the symmetric curve, already in the properties we know that it is in a bell shaped, so it will comes like this. It will comes like this, and it will be symmetric. X bar is equal to median is equal to mode. This is symmetric. So the property says that it is bell shaped, so it is a bell shaped curve and it is symmetric. If it is a positively skewed distribution, the positive to the right side you will get the values. For negatively skewed distribution you will get the left side values. Next is measures of skewness. The measures of skewness may be absolute or relative measures. Absolute measures are expressed in the units of distribution. It cannot be used for the comparison with another distribution with different units. Absolute measure we cannot take it with the units and we cannot compare with any other distributions. So we will not take absolute measures for skewness, we will take the relative measure of skewness. These relative measures are known as coefficient of skewness. Some important concepts of skewness are we are going to study now. Okay, we are using relative measures of skewness or coefficient of skewness, and types important measures are Karl Pearson's coefficient of skewness, and second one Bowley's coefficient of skewness, and next is measures of skewness based on moments. But for your exam point of view, Karl Pearson and Bowley's coefficient of skewness are very, very important. And Karl Pearson's coefficient of skewness based on mean, median, mode and the standard deviation, whereas Bowley's coefficient based on purely based on quartiles. Next is kurtosis. So far we have studied about some central values, dispersions, skewness to describe the characteristics of frequency distribution, and these three measures are not enough to characterize distributions completely. So symmetrical, if the curves are symmetrical about the mean and also have same variation is nothing but the range, the highest and the lowest value, but the shape and peakedness, how much it is accurate of the curves are different. This type of peakedness of the frequency curve is called kurtosis. First I will write what is the meaning or definition of kurtosis. Definition: kurtosis. Kurtosis means peakedness in the region of mode of a frequency curve. Based on this, the peakedness, we will divide the distribution into three types. So I will write here. Sorry, I want peakedness. Yes. Here if peakedness is like this and it is symmetric and this is symmetric, even though all the shapes are bell shaped, but when the beta values, depending on the beta values, if this is highest peakedness, this is, call it as leptocurtic, and here beta 2 is greater than 3, and this is called mesocurtic. Here beta 2 is equal to 3, and this is platycurtic. Beta 2 is less than 3. You just observe the mesocurtic, it is not too sharp or not too flat. but it is in a moderate way. So this is when beta 2 value is equal to 3, and this curve we call it as mesocurtic, and it is taken as standard to mesocurtic, and that mesocurtic we will always take it as a standard curve or a bell shaped curve. Curve which is more peaked than a normal curve is called leptocurtic. Since this is a normal curve, peakedness is more in this leptocurtic, and this is more greater to this one. So this is leptocurtic, and another one is the curve which is less peaked than a normal curve. This is called platycurtic. At output it is tends to flat, so it is a platycurtic. Let us see some problems on coefficient of skewness. Calculate Pearson's coefficient of skewness for the following data. Class interval frequencies 300 to 400 to 500. This is the data they have given. In exam also you will get this type of problem for 10 marks, that is Kpis coefficient, and you will get only for class interval problems. And here they have given class interval and frequencies. The formula to find Kpis coefficient, first I will write that. The formula to find Kpis coefficient is Carl Pearson's or Kpis coefficient of skewness is equal to x bar minus z divided by sigma. X bar is nothing but a mean, z is our mode, and sigma is standard deviation, and this is the formula for continuous frequency distribution. And here we have only one mode value. Mode value is only one mode value we are having, that is only one highest frequency is there, that is 76. Okay, so for this data we have to calculate mean, mode and standard deviation. Let us solve that. You know how to find mean, standard deviation and a mode for a continuous frequency distribution. So again I will recall those things. To find x bar is equal to summation of fx divided by n. Summation of fx divided by n. So first thing is I want midpoint. Midpoint is our x. Midpoint is x. So here the midpoint for this is 350, 450, 550, 650, 750, 850, 950, 1050, 1150. The next step is, here we are having a big number in x value. We will go for a deviation, that is u is equal to x minus a, and here a is a smallest number. Here a is smallest number. A is equal to 350. A I will take it as 350. Smallest number here I will take. So this is our a value, and this 0, 1, 0, 100, 200, 300, 400, 500, 600, 700, 800. And again for this I will take u dash. U dash is x minus a divided by c. Here c is equal to what, the width of the class interval, that is 100. And here this will become 0, 1, 2, 3, 4, 5, 6, 7 and 8. Next thing is F into U dash. F is frequency column, should be multiplied by U dash column. So multiply these two columns, you will get FU dash, that is 0, 46, 116, 228, 272, 310, 288, 154, 48, and the total of this is summation of FU dash is equal to 1462. So substitute that to find x bar. To find x bar, here I will write A is equal to 350 and C is equal to 100. X bar is equal to capital A plus summation FU dash by N into C. So A is equal to 350 plus 1462 divided by N. N is equal to 400. Substitute the values into C is also 100 and your x bar value is 715.5. Next you find a sigma value, that is sigma is equal to summation of FU dash square. Instead of taking x square, I have taken FU dash square in N minus summation of FU dash divided by N the whole square, the square root. Should be multiplied this by C. C is nothing but the width of the class interval, and this is FU dash square. FU dash square is nothing but FU dash into U dash. You know that Fx square is Fx into x. Similarly, FU dash square is FU dash into FU dash. FU dash into U dash. This will be 46, 232, 684, 88, 550, 1728, 1078, 384, and this total is 6790. So substitute the values. 6790 by 400 minus 1462 by 400 the whole square into 100. Your C is equal to 100. So your sigma value is 190.15. 190.15. So after find x bar and sigma value, the next is we have to calculate the mode value. Here in this distribution, the highest frequency is 76. Only one value we are having highest in frequency. So 76 is the highest. Therefore it is a unimodal. So find the Z value. Z or nothing but Z is nothing but Z is L plus Fm minus F1 by 2Fm minus F1 minus F2 into C. Here 76 is the highest one. So this is your Fm, F1 and F2. You know how to take that and you know how to calculate that also. So substitute the values. So Z is equal to 600 plus 76 minus 58 divided by 2 into 76 minus 58 minus 68 into C is equal to 100. So calculate after simplification, your Z is 669.23. 669.23. After finding this x, sigma and Z value, calculate Kpis coefficient. Kpis coefficient is equal to x bar minus Z by sigma. So this is 71.5 minus 669.231 divided by 190.15. So this is 0.243. Kpis coefficient is 0.243 and here it is a plus value. So as the coefficient of skewness is positive, the distribution is positively skewed. Okay, here if we get a positive value, so the distribution is positively skewed distribution. Positively skewed distribution. In examination for this comment also you will get the marks. You will get 1 marks for this comment, and this is very very important concept for your examination. Okay. Next problem. Same, we have to calculate the coefficient of skewness, class interval, frequencies. Yes. See, first you observe the distribution. Here to find Kpis coefficient we want to find z value, but z is nothing but our mode value. So but in this distribution we have two highest frequencies 40. It is repeated 2 times for 2 class intervals. So we cannot calculate mode for this bimodal, because we are having 2 modes. So we cannot calculate the 2 modes for Kpis coefficient. So we will go to another formula. We are having another formula to find Kpis coefficient when it is a bimodal, that is 3 times x bar minus median divided by sigma. Instead of calculating the mode value, we will calculate the median value, and the formula is this. So for this one we have to calculate mean, median and standard deviation. The procedure will be same, there is no difference about that. Okay, let us start. First I will find the midpoint, that is our x. So midpoint is 5, 15, 25, 35, 45, 55, 65, 75. I will write u dash. U dash is nothing but x minus a by c. A value is equal to, here I will write, a is equal to first value, that is middle value, that is a is equal to 35, and u is equal to the width of the class interval, that is 10. So directly I will take, to find minus 2, minus 1, 0, 1, 2, 3, 4. Next is fu dash and fu dash square. Complete the table till here so that you can calculate easily. So here n value is 150. Fu dash, I am going to write the fu dash values. F into u dash, it is minus 30, minus 8, minus 20, 0, 10, 80, 48, 56, and this total is 64. Fu dash square is fu dash into u dash, it is 90, minus 160, 20, 0, 10, 160, 144, 224, 808. Next step, find the mean value, that is a plus summation fu dash divided by n into c. So x bar is equal to 35 plus 64 by 150 into 10. So x bar is equal to 39.267. X bar is 39.267. Next is sigma. Sigma is summation of fu dash square by n minus summation of fu dash by n, the whole square, the square root into c, and this is square root of 808 by 150 minus 64 divided by 150 whole square into 10. This 10 should be outside the square root, otherwise I'll write this in a bracket. At last you should multiply, so your sigma value is 22.81. After simplification you will get 22.81. And next is you have to find median instead of mode. To find the median we want LCF. To find the median we want LCF. Here I will write the LCF. Oh, we cannot write the LCF here. Okay, I will write somewhere here. This is LCF. I will write u dash is equal to x minus a by c. This is minus 3, minus 2, minus 1, 0, 1, 2, 3, 4. LCF, you know how to find LCF. The first frequency will remain same. You should add this to second frequency. It will be 50, 70, 70, 80, 120, 136 and 150. After finding the LCF, the next step is find to median is n by 2. N by 2 is 150 by 2. It is 75th observation. 75th observation. 75 you will get in 80. 75 you will get in 80. So you have to block this one. You have to block this one. And this is your previous one will be your CF. I will bifurcate this like this. This is your CF. CF and this is your F. Now you calculate the median. Median is equal to L plus n by 2 minus CF by F into C. So this is L is equal to 40 plus n by 2 is 75. CF is equal to 70 by 10 into 10. This is 45. So our median value is 45. Now you substitute everything in Kpis coefficient. It is 39.267 minus 45 divided by 22.81. So Kpis coefficient is equal to 0.754 minus 0.754. Here we got minus value, so the distribution is negatively skewed distribution. Negatively skewed distribution. Since we have got Kpis coefficient in negative, so the distribution is negatively skewed distribution. Next, compute Bowley's coefficient of skewness. Bowley's coefficient of skewness. Here it is x and f. 0, 1, 2, 3, 4 and 5. Okay. 6, 50, 25, 8, 4 and 1. To find the Bowley's coefficient, we have a formula, that is Bowley's coefficient of skewness is Q3 plus Q1 minus 2Q2 divided by Q3 minus Q1. Already I have told that Pauli's coefficient is purely based on quartiles. So we have to calculate all the three quartiles, that is Q1, Q2 and Q3. Since this is a discrete case, so it is very easy to calculate the Pauli's coefficient. First step is we have to find the LCF. 6, 21, 46, 54, 58, 59, and your n is also 59. To find Q1, it is 1 into n plus 1 by 4. Fourth observation. So it is 59 plus 1 by 4. It is 60 by 4. It is 15th observation. 15th observation we can see in 21 LCF. So this is our Q1. This is our Q1. So Q1 is equal to 1. Next, to find Q2, 2 into n plus 1 by 4. This is 2 into 15. This is 30th observation. 30th observation should be seen in 46. So this is our Q2. So Q2 is equal to 2. Next, to find Q3, 3 times n plus 1 by 4. This is 3 into 15. This is 75th observation. And our Q3 value is 45. 45. 45 should be seen in 46. 46 only. So this 2 is for Q3 also. So Q3 is also 2. So substitute Q1, Q2, Q3 values in Pauli's coefficient. This is 2 plus 1 minus 2 into 2 divided by 2 minus 1. This is minus 1 by 1. This is minus 1. So Pauli's coefficient is minus 1. Since we got a negative value, that is minus 1, so the distribution is negatively skewed. So we got negative value, the distribution is negatively skewed distribution. Find the measures of skewness based on quartiles. We have completed and we'll move on to some other problems. 2 marks problem. The mean and mode of weekly wage of a group of workers are rupees 45 and rupees 6 respectively. If standard deviation is rupees 18, then find the coefficient of skewness. Then find the coefficient of skewness. So here they have given mean, mode and standard deviation values. The coefficient of skewness, that is Kpis coefficient. Kpis coefficient is equal to x bar minus z by sigma. Here x bar is equal to this one 45 minus 6 divided by 18. So Kpis coefficient is equal to 0.5. Kpis coefficient is equal to 0.5. Next, the mean of a distribution is, the mean of a distribution is 23. median is equal to 25 and sigma is equal to 10. Calculate Kpis coefficient. Since this here they have given the median value, so the Kpis coefficient is 3 times x bar minus median divided by sigma, and this is 3 into 23 minus 25 by 10, and this is minus 0.6. Minus 0.6. In the distribution, the first quartile, that is Q1 is equal to 142. Semi-interquartile range. Semi-interquartile range is nothing but Q3 minus Q1 by 2 is equal to 18. If the distribution is symmetric, then find second quartile. Second quartile. See, they have given Q1 value and interquartile range is nothing but Q3 minus Q1 by 2, that is QD, and the distribution is symmetric. Since the distribution is symmetric, it will be equidistant, so that we can write it easily, and we have to find second quartile. First we will, here they have given Q1 is equal to, this is a solution, 142, and Q3 minus Q1 by 2 is equal to 18. So Q3 minus Q1 is equal to, find the value of Q3 using this relation. So it is 36. So Q3 is equal to 178. This implies Q3 minus 142 is equal to 36. So Q3 is equal to 178. So after finding Q3, since the distribution is symmetric, we know that distribution is symmetric. Distribution is symmetric. So Q3 minus Q2 is equal to Q2 minus Q1. The properties of symmetric distribution says that Q3 minus Q1 is equal to Q2 minus Q1. So Q2 is equal to Q3 plus Q1 by 2. Therefore, Q2 is equal to 178 plus 142 divided by 2. So Q2 is equal to 160. Q2 is equal to 160. For a distribution, Bowley's coefficient is equal to minus 0.36. Lower quartile, that is Q1 is equal to 8.6, and median or nothing but Q2 is equal to 12.3. Find the upper quartile. We have to find upper quartile. They have given the Bowley's coefficient. So Bowley's coefficient, first we will write the formula for this. So Q3 plus Q1 minus 2Q2 divided by Q3 minus Q1. Substitute the values. Here Bowley's coefficient they have given, this is minus 0.36, that is equal to Q3, that is upper quartile we have to find. Q3 plus Q1 is 8.6 minus 2 into 12.3 divided by Q3 minus 8.6. You just take the cross multiplication first. It is minus 0.36 Q3 minus into minus plus 3.096 is equal to Q3 plus 8.6 minus 24.6. Take all the Q3 values to one side. So here it is 1. There is no coefficient, means it is coefficient of Q3 is 1. It is minus 0.36. If I shift this to this side, it will become positive. So it will be 1.36 Q3 is equal to 19.096. So Q3 is equal to 14.04. Q3 or upper quartile is 14.04. So this is all about your last concept in analysis of univariate data. So we have solved the very important problems. Kpis coefficient problems you will get for 10 marks and Bowley's you will get for 5 marks. Sometimes that is also for 10 marks, and this is a very important concept in analysis of univariate data. Thank you.